Good evening, guys. Am I audible?
Yes, sir.
Okay. So we have completed the introduction to combinations, right? Now we saw these relations also. 5p3 is written as 5c3 into 3 factorial. We have written it like this, no? Which is 5 factorial by 5 minus 3 the whole factorial into 3 factorial, which is also given as 5c3. Right. Similarly, NPR is written as NCR multiplied with R factorial. Okay. So next is, we saw that NC N minus R is also same as NCR. Last class I told you, that is 5C3 is the same as 5C 5 minus 3. That is 5C3 is equal to 5C2. Okay. Similarly, NCA is equal to NCB is possible when the value of A is equal to B or A is equal to N minus B. Or we can write N is equal to A plus B. Right? N is equal to A plus B. Right? So here, try to understand, when I say NCA is equal to NCB, right? Remember, NCB can also be written as NCN minus B according to the previous property. So when that is the case, I can equate A is equal to N minus B, which implies A plus B is equal to N. Right? Which implies A plus B is equal to N. Okay. Next. Theorem number 6 states NCR plus NCR minus 1 is equal to N plus 1 CR. This is another important property that we need to have in mind. So NCR plus NCR minus 1 is equal to N factorial by N minus R factorial plus N factorial divided by N minus of R minus 1 factorial. Right? So this will give us N factorial by N minus R factorial plus N factorial divided by N minus R plus 1 factorial. N minus 1, N minus R plus 1 factorial. This will be equal to N factorial by N minus R factorial plus N factorial divided by N minus R plus 1 into N minus R factorial. n factorial divided by n minus r factorial into 1 into 1 plus 1 by n minus r plus 1. Okay. So this will be equal to n factorial by n minus r factorial into n minus r plus 1 the whole divided by n minus r plus 1. Is that right? Is that right? One minute. It is basically n factorial divided by n minus r factorial into r factorial, sorry. Into r factorial into r minus 1 factorial. Okay. So it is n factorial divided by n minus r factorial into r factorial plus n factorial divided by n minus r plus 1 factorial into r minus 1 factorial. So what we can do here is this part is there. No, here I will write it as r into r minus 1 factorial, and this one I will write it as n minus r plus 1 into n minus r factorial. This is equal to n factorial divided by n minus r factorial into r minus 1 factorial, right, into 1 plus into 1 by r plus 1 by n minus r plus 1. Right, 1 by r plus 1 by n minus r plus 1. Okay. This will be equal to n factorial divided by n, 1 minute, sorry, n minus r factorial into r minus 1 factorial into n minus r plus 1 plus r, n minus r plus 1 plus r divided by r into n minus r plus 1. So r and r will get cancelled. Now observe, n factorial into n plus 1 is n plus 1 factorial, the whole divided by n minus r plus 1 into n minus r factorial is n minus r plus 1 factorial into r factorial. So this will be equal to n plus 1 CR. This will be equal to n plus 1 CR, and this is what is given here.
Sir, can you please go to the previous slide? Yes, sir.
So can we go to the previous slide one?
This one?
Yes. Yes.
So this is the proof in the textbook. There is also a part of this. Okay. So based on the concepts that we have discussed, let's try out some problems. If NC9 is equal to NC8, find NC17. So we know that NCA is equal to NCB, that is also equal to NCA plus B, that is NC17, because here A is 9, B is 8. Okay. So first we'll find out the value. Okay, we'll try to find out what the value is. When I say NC9, it is n factorial by n minus 9 factorial into 9 factorial is equal to n factorial by n minus 8 factorial into 8 factorial. N factorial and n factorial are gone. 8 factorial will cancel this 9 factorial 9 times. N minus 8 factorial will cancel this. Sorry, n minus, yeah, n minus 8 factorial will cancel this n minus 9 factorial n minus 9 times. So which implies 9n minus 81 is equal to 0, which implies n is equal to 9. But how can n be 9? 1 minute. So n factorial by n minus 9 factorial into 9 factorial is equal to, oh, sorry. Mistake here. N minus 9 factorial will cancel n minus 8, n minus 9 times. N minus 8 times, sorry. Why is it so? Because I'll write every step and show you. See, I'll write every step and show you. Observe. So n factorial by n minus 9 factorial into 9 factorial is equal to n factorial by n minus 8 factorial into 8 factorial. So n factorial and n factorial will get cancelled. 1 divided by n minus 9 into, sorry, n minus 9 factorial is left as it is. Into 9 factorial, I can write it as 9 into 8 factorial is equal to 1 divided by n minus 8 factorial can be written as n minus 8 into n minus 9 factorial into 8 factorial. So 8 factorial gone, n minus 9 factorial, n minus 9 factorial gone, which implies n minus 8 is equal to 9 or n is equal to 17. So what they are asking is 17C17, which will be 1 itself. NCN is 1. Did you all copy it?
Yes.
So next. A committee of 3 persons is to be constituted from a group of 2 men and 3 women. In how many ways can this be done? How many of these committees would consist 1 man and 2 women? A committee needs 3 persons, right? So totally how many people do you have in your hand? Two men plus 3 women. It is going to be 5. 1 minute. Okay. So 2 men and 5 women put together is 5 people. So how will you form a committee?
5C3, sir.
It should be 5C3. A committee of 3 persons to be constituted from a group of 2 men and 3 women. So it should be 5C3. On it, I have to take a message. Yeah, done. So what was it? We answered. So out of the 5 people, we need to form a committee of 3 people, right? So it is going to be 5C3, which is going to be 5 factorial by 2 factorial into 3 factorial, which is 5 into 4 into 3 factorial divided by 2 factorial into 3 factorial. 3 factorial and 3 factorial is gone. So answer should be 10. I hope it is clear. Right. So how many of these committees would consist of 1 man and 2 women? So out of the 2 men available, you need to choose 1, and out of the 3 women available, you need to choose 2, which implies this is equal to 2 factorial by 1 factorial into 1 factorial into 3 factorial by 1 factorial into 2 factorial. So that will be 2 factorial into 3, which will be 6. So it can consist of 6 such combinations. Okay. So tell me how to solve the 19th one. What are the number of ways of choosing 4 cards from a pack of 52 playing cards? In how many of these 4 cards are of the same suit? What is the number of ways of choosing 4 cards from a pack of 52 playing cards? In how many of these 4 cards are of the same
C,
suit? Sorry?
C4.
So you have 52 cards. Out of the 52 cards, you need to choose 4. So answer will be 52C4. So that is, sorry, in how many ways the number of cards, number of ways of choosing 4 cards, it is going to be 52C4s. So 4 cards of the same suit. So 4 cards of the same suit. So how many such suits are there which contain the same number of cards? 4. So 52 by 4 is going to be 13 cards. So 13 cards are going to be of the same suit. Out of the 13 cards, we are going to choose 4. 13C4. That is the answer for the First one. 4 cards belong to 4 different suits. Actually, yeah, 4 cards of the same suit means it could be any of the 4 cards from the 13 cards, or any of the 4 cards from the 13, or any of the 4 cards from 13, or any of the 4 cards from 13. Did you understand? So there are 2 blacks and 2 reds. No. Heart, diamond, club, and spade. So they're going to be 13 cards each. So from each, you're going to take 4 means 13C4. Since it is going to be OR, it can either be from heart, it can be from diamond, it can be from spade, or it can be from a club. So since it's an OR operation, you need to use plus in between. Is there anyone having doubt in this?
No, sir.
Okay. 4 cards belong to 4 different suits. So from the first suit, you will choose one. And from the second suit, you will choose one. And from the third suit, you will choose one. And from the fourth suit, you will choose one. So 13C1.
Sir,
So
is it
13C1, it is into sorry. So 13C1 into 13C1 into 13C1 into 13C. For the third one, what is going to be the answer? Or sorry. All are face cards. So how many face cards are there?
12?
What are they?
King, queen, and jack.
Into 4. So out of the 12 cards, you need to choose 4. Is that right?
Yes, sir.
Next. So what about the fourth one? So 2 red cards and 2 black cards. So 26C2 and 26C2. So there are 26 red cards and 26 black cards. So out of the 26, out of the 26 red, you need to choose 2. And out of the remaining 26, you need to choose 2. That is why it is 26C2 into 26C2. Am I correct?
Yes.
So cards are of the same color. Cards are of the same color. So you can, out of the 26 red cards that are available, you can choose any 4, or out of the remaining 26 black cards, you can choose any 4. So that is the answer for the fifth one. So 26C4 or 26C4. Okay. Are you done? Shall I proceed?
Yes.
Yeah. So the first problem in the exercise is going to be, if NC8 is equal to NC2, find NC2. See, NC8 is equal to NC2. If NCA is equal to NCB, that implies N is equal to A plus B, which implies N is 10. Am I right? So all that they're asking is 10C2. What is 10C2? It is 10 factorial by 8 factorial into 2 factorial, which is 10 into 8, 9 into 8 factorial. The whole divided by 8 factorial into 2 factorial. So 8 factorial gone. 2 will cancel this 5 times. So answer will be 45. So 10C2 is 44. Okay. Second, determine n if 2nC3 is to nC3 is equal to 12:1. So 2nC3 divided by nC3 is equal to 12 divided by 1, which implies 2n factorial by 2n minus 3 factorial into 3 factorial divided by n factorial by n minus 3 factorial into 3 factorial is equal to 12 divided by 1. So 3 factorial is gone. So 2n factorial can be written as, listen to this carefully, it is 2n into 2n minus 1 into 2n minus 2 into 2n minus 3 factorial, the whole divided by 2n minus 3 factorial, this whole thing divided by n into n minus 1 into n minus 2 into n minus 3 factorial, the whole divided by n minus 3 factorial. N minus 3 factorial, n minus 3 factorial is gone, right? 2n minus 3 factorial and 2n minus 3 factorial is gone. N and n will get cancelled. So n minus 1 will cancel 2n minus 2 two times, right? 2 times. Right? So 2 into 2 is 4 into 12 is 3. 2n minus 1 divided by n minus 2 is equal to 3. 2n minus 1 divided by n minus 2 is equal to 3, which implies 2n minus 1 is equal to 3n minus 6, which implies n is equal to 5. Right? N is equal to 5.
So can you show the previous page?
Sure.
There's an answer.
Try the next one. You people try it. So what is the answer for that? 2nC3 is to nC3 is equal to 11 is to 1. So 2nC3 is to nC3 is equal to 11 is to 1. So 2n factorial divided by 2n minus 3 factorial into 3 factorial, the whole divided by n factorial by n minus 3 factorial into 3 factorial is equal to 11 by 1. 3 factorial and 3 factorial are gone. So again the same logic, no? So whatever happened here will come out. So you will have 4 into 2n minus 1. 4 into 2n minus 1, the whole divided by n minus 2 is equal to 11 by 1, which implies 8n minus 4 is equal to 11n minus 22. So 3n is equal to 18. So n will be equal to 6. Is the point clear? So n will be equal to 6. Is it clear? So next is, how many chords can be drawn through 21 points on a circle? So 21 points are there. For drawing a chord, you need to choose 2 points. So 21 C2 will be the answer. It is 21 factorial. It is 21 factorial divided by 19 factorial into 2 factorial, which will be 21 into 20, the whole divided by 2. It will be 10. So it will be 210. There will be 210 chords that can be drawn. In how many ways can a team of 3 boys and 3 girls be selected from 5 boys and 4 girls? So out of the 5 boys available, you can choose 3 boys, and out of the 4 girls available, you can choose 3. So it is 5C3 into 4C3. So it will be 5 factorial by 2 factorial into 3 factorial into 4 factorial divided by 1 factorial into 3 factorial. So it is 5 into 4 into 3 factorial divided by 2 into 4 into 3 factorial divided by 3 factorial. These two will get cancelled. So 3 factorial is 6, 6 into 2 is 12, 12 into 5, 60, 60 into 4 is 240 ways. Wait. 2 into 3 factorial, this and this will get cancelled. So correction. So it will be 10 into 4, 40 ways. The 3 factorial gets cancelled, no? Next. So find the number of ways of selecting 9 balls from 6 red balls and 5 white balls and 5 blue balls if each selection consists of 3 balls of each color. So from the 6 red balls, you need to choose 3 into the 5 red balls, you need to choose 3 into the 5 blue balls, you need to choose 3. So 6C3 into 5C3 into 5C2. Determine the number of 5 card combinations out of a deck of 52 cards if there is exactly 1 ace in each combination. So how to do this? Are you guys even there?
Yes, sir.
Yes, sir.
So how to do this problem? Sorry?
Trying, sir.
What is the answer?
Sir, I'm getting a,
Can you tell me the logic? So
Sir,
you have to pick cards, out of which you need to pick 5. But what are the condition they have imposed?
sir,
Ah, yeah,
sir,
tell me.
I'm getting a very weird, large number, sir, 7.
I don't want the final answer. I only ask what is the value you
Sir,
write it.
Sir, 48 C4 into 4 C1.
Logic. Tell me the logic. Tell me the
Sir,
logic.
we have 4 ace cards and 50 deck of 52 cards, sir. And
So,
due,
there is
because,
Yeah.
and the question says we need to select 1 ace card out of 4 ace cards, sir. That is,
So that should be the first condition. So
that
out of
will be the first.
out of the 4 ace card, you need to choose one. And how many cards are remaining now?
51 cards will be remaining, sir.
It's not 51.
I mean, 52 minus 4 ace cards. So it is
Ah.
48 ace cards will be.
So
Cards will be
48,
remaining, sir.
48 non-ace cards are remaining.
So it's
out of
48 C4
Yes.
into 4 C1, sir.
Why into 4C1?
I mean, we have 48 C4, sir. So we need to determine one C ace card, how many combinations, and without without the ace cards, how many combinations can
That's not a part of our job. No, they've mentioned that there is exactly one ace card in each combination.
Yes, sir. But we also need to take. There was number of 5 card combinations, sir.
Not necessary. In that 5 card combination, this condition is imposed. You need not do that. You need not do that at all. So if you have written plus 52 C5, you're wrong.
No, not plus, sir. Multiplied by 48 C4.
You cannot do. See, first of all, understand one thing. Whenever you write this kind of an equation, no, everybody listen. After you write this 4C1 into 48 C4, no, what you need to do is you need to count the bottoms and see. So when you count the bottom, how much are you getting? 5. That 5 is what this number is. When you count the tops, so 48 into 4, that's what this number is.
Yes, sir. I also told this 48 C4 into 4 C1.
That's what. Then why are you again writing 48 C4?
No, sir. I told 4 C1 into 48.
That's what. And
I
then we
just
have
told once. And doing solving this, I get 7,78,320.
So that I don't know.
This
7 lakh?
78,320.
330.
20.
20. Okay.
I took 4 factorial into.
That's fine. See, that part you can do it. That I need not solve. No, I'm only concerned about logic here. That part I'm leaving it to you.
Yes, sir.
So in how many ways can one select a cricket team of 11 from 17 players in which only 5 players can bowl? If each cricket team of 11 must include exactly 4 bowlers. So first, whatever is the condition, you need to write the combination for that. Out of the 5 players that are available, there are 4 bowlers. So it is 5C4 into how many are remaining? From 17, 5 are gone. So it will be 12. Out of the 12, you need to choose the remaining 7. So 5C4 into 12C7 will be the answer. Is the point clear? Next, solve this. A bag contains 5 black and 6 red balls. Determine the number of ways in which 2 black and 3 red balls can be selected. So out of the 5 black balls, you choose 2 black balls, and out of the 6 red balls, you choose 3 red balls. So it is 5C2 into 6C3. Okay. Next. In how many ways can a student choose a program of 5 courses if 9 courses are available and 2 specific courses are compulsory for a student? So the 2 compulsory courses can be selected in 2C2 ways. Am I right? Into out of the 9 courses, 2 are compulsory means how many are remaining? Out of the 7 remaining courses, he needs to choose the remaining 3 courses. Are you able to understand this point? Are you able to understand or not?
Yes, sir.
Okay, next. I think the problems are done. This is the last problem in the textbook.
Yes, sir.
So now I think we are ready for the miscellaneous part, no? One minute. So we'll start with the miscellaneous problems. Tell me, how are we supposed to solve this? How many words with or without meaning, each of 3 vowels and 2 consonants can be formed from the letters of the word involute?
Three C4 into 2C4, sir.
Come again?
3C4 into 2C4.
Sir, 4C3 into
It's not 3C4, no, see, observe. Listen. First of all, tell me, is this a problem based on combination or permutation? It is based on permutation. Right? How many words with or without meaning, each of 3 vowels and 2 consonants can be formed? So that word should be a 5-lettered word, for which you need to have 3 vowels in it and 2 consonants in it. First of all, let's calculate the vowels in the word that is given to us. What are they? I, O, U, E. What about the consonants? N, V, L, T. Right? So out of the 4 vowels available, you need to choose 3 into, out of the 4 consonants that are available, you need to choose 2. So it is 4C3 into 4C2. But out of the 5 words that you have selected, they can be arranged among themselves in 5 factorial ways. So this should be the answer. Did you understand? Did you understand what I did? Out of the
Yes.
4 vowels, you need to choose 3. And out of the 4 consonants, you need to choose 2. Into these 5 words can be arranged, 5 letters can be arranged among themselves in 5 factorial ways. Okay. Right. Tell me how to do this problem. A group consists of 4 girls and 7 boys. In how many ways can a team of 5 members be selected if the team has no girl, at least 1 boy and 1 girl, at least 3 girls? A group consists of 4 girls and 7 boys. In how many ways can a team of 5 members be selected? If for the first one, if no girl is selected from the 7 boys available, you need to choose 5. Second, at least 1 boy and 1 girl. At least means how will you write it?
Minimum 1 boy, maximum.
Yes, at least 1 boy and 1 girl. So how to write the equation for that? So at least 1 boy and 1 girl, how will you write the equation? See, out of the 4 girls available, you can choose 1 girl, and out of the 7 boys available, you can choose 4. Or 4C2 into 7C3, or 4C3 into 7C2, or 4C4 into 7C1. Make sense? So these are all the possible ways in which you can form a group. So you talk about the group, right? Boy 1 and boy 2, or boy 2 and boy 1, order is not important. So it falls under combination. So third, at least 3 girls. At least 3 girls means out of the 4 girls, you can have 3 into 7C2 or 4C4 into 7C1. That's it. Is that point clear?
Yes.
Yes.
The next one is a good problem. Find the number of words with or without meaning which can be made using all the letters of the word again, if these words are written as in dictionary. Okay, find the number of words with or without meaning which can be made with the letters of the word again. So how many are there? 1, 2, 3, 4, 5. So it is going to be 5 factorial divided by A is repeating itself 2 times. So 5 factorial divided by 2 factorial. That is the answer for the first part of the question. The second part, what are they asking? If these words are written as in the dictionary order, if these words are written as in the dictionary order, what will be the 50th word? Okay. If they have to be written in the dictionary order, tell me what should be the, so 5 blank spaces are there. 1, 2, 3, 4, 5. In the 5 blank spaces, what will be the first letter? It will be A. So what should be the second letter? That should also be A. Right? Then these words can be arranged among themselves. The 3 remaining letters can be arranged among themselves in 3 factorial ways. Am I right? So after this, what will you have? 1, 2, 3, 4. So after the second letter being A, what should be the next letter that should come after A?
Perfect.
Okay. Can we do it in a simpler way? Actually, if you observe, I can simplify this also. See, if I start the first letter with A, how many blank spaces are left out?
4.
4. These 4 blank spaces, the 4 letters can be filled in 4 factorial ways. What is 4 factorial? It is 24. So we have not yet reached 50. So after A is over, what will be the next letter that it will start with? G. Am I right? G. So here, how many ways can you fill them? You can fill them in 4 factorial divided by 2 factorial, because A will repeat twice. So 4 factorial by 2. So 4 factorial is basically 24. 4 factorial by 2 factorial is 12. After G, what will come? I will come. 1, 2, 3, 4. So how many will be there? It will be 4 factorial divided by 2 factorial, which is going to be 12. So 24, 12, and 12. So how much is that? 36 plus 12. It is going to be 48. So 48 words are over. So the next word should start with N. So after N, tell me what should be the next letter here? It should be A. And what should be the next letter here? This should also be A. And what should be the letter here? It should be G and it should be I, if you go in the order. So this will be the 49th word. I hope you are able to understand. Because first 24 words are starting with A. The next 12 words are starting with G. The next 12 words are starting with I. So after you start with the next letter that is left out, N. So since you have to go in the dictionary order, after N, for it to be in the dictionary order, the next letter is supposed to be A. The subsequent letter should be A, followed by G, and then I, which will be the 49th word. So the next letter also, sorry, the next word will also be N, A, but G and I will get swapped. So this will be the 50th word. So NAAIG is going to be the 50th. Okay. Next is, how many numbers greater than 1, 10, 100, 1000, 10,000, lakh, 10 lakh? So how many numbers greater than 10 lakh can be found by using the digits 120, 24, 24? So what will be the answer? Since the number expected is supposed to be greater than 10 lakh. So what should be the first digit that it can take? 1. So how many zeros are there? 1, 2, 3, 4. Sorry, how many spaces are left out? 6 blank spaces. For the number to be greater than 1 lakh, sorry, 10 lakhs, what should be the next digit? Why are you guys not responding? I didn't get you.
Solving.
Solving. Okay, solve and tell me.
Sir, is it 360?
Huh?
360.
I don't know, but tell me the logic. See, it should start with 1. Right? Now tell
Sir,
me what is, yeah. Tell me.
there are 6 blank spaces and 6
Correct.
so 6 factorial ways and 3
So
times 4. 2 is repeated thrice, so 3
okay,
factorial
so
and
3 factorial
4
into,
into 2 factorial because 4 is repeated twice.
correct. So how much is this coming out to be?
60.
It's 60. Yeah? I'm not calculating. Okay. 60. Next, what are we supposed to do?
Number starting with 2.
Okay. Number starting with 2. So 6 blank spaces. So 6 factorial divided by,
2 factorial into 2 factorial.
yes, because one of the 2's is utilized in the first position. So 2 factorial into 2 factorial. How much is this coming out to be? How much is this?
1.
See, 6 factorial is 720. 720 by 4 should be 180. Next.
Starting with 4.
Okay. 1,
6
2, 3, 4,
factorial by 3.
3 factorial and 4 factor 4 you can the next 4 is going to come only once. So 6 factorial by 4 factorial. 720 by 3 is going to be 240. So 240 plus 180 plus 60. So 240 only, no?
Sir, 120, sir.
720 by 1. Okay, sorry. 720 by 6, no. It is 120. So 300, it is 360. Correct. Correct. So let me copy and paste the next question. In how many ways can 5 girls and 3 boys be seated? In how many ways can 3 girls and 5 boys be seated in a row so that no 2 boys are together? Since the condition is imposed on no 2 boys are together, whom will you make sit first?
Girl.
So they told you need to make them sit in a row. So girl, 5 girls. So leave the blank spaces here. So you can leave the blank spaces on the other side also. So how many blank spaces do you have? 1, 2, 3, 4, 5, 6. Right. So tell me one thing. These 5 girls can be arranged among themselves in how many ways? They can be arranged among themselves in 5 factorial
5
ways.
factorial.
Into how many blank spaces are there? 1, 2, 3, 4, 5, 6. In the 6 blank spaces, you can make the 3 boys to sit. So it is 6p3. Am I right?
Yes,
So
sir.
5 factorial is going to be 120 into 6 factorial by 3 factorial will also be 120. So it should be 14400. First 12 square is 144. So 2 zeros. Is the point here?
Yes, sir.
Perfect. How many words with or without meaning, each of 2 vowels and 3 consonants can be formed from the letters of the word daughter? How many words with or without meaning, each of 2 vowels can be two vowels and three consonants can be formed from the letters of the word daughter. So how many vowels are there? A, E,
E,
U. That's it. How many consonants are there?
5.
What are they? D,
G, H, T, R.
D, G, H, T, R. Right. So out of the three vowels available, you need to form a word with two vowels. So how much will be the answer? It is 3P2 into, sorry, not 3P2. You need to choose to know. So 3C2 into, out of the 5 consonants that are available, you will choose 3 into, you have chosen those 5 letters, no? Those 5 letters can be arranged among themselves in 5 factorial ways. So 3C2 into 5C3 into 5 factorial. Okay. How many words with or without meaning can be formed using all the letters of the word equation at a time so that the vowels and consonants are together? So when you take the word equations, so what are the vowels you have? A, E, I, O, U. This should be treated as 1. What are the consonants that you have? They are Q, T, O, N, S. Sorry, Q, T, N, S. Right? No.
Sir, only equation, sir.
So
S is
equation
not there.
S is not there. Okay. Now this can be treated as one letter. So totally all the vowels put together is one item and QTN put together, the consonants put together is one item. So these two items can be arranged among themselves in 2 factorial ways into the vowels can be arranged among themselves in how many ways?
4 factor.
5 factorial. All the 5 are there, no? Into the consonants can be arranged among themselves in
4 factor. 3.
3 factorial. Yes. So 3. A committee of 7 has to be formed from 9 boys and 4 girls. In how many ways can this be done when the committee consists of exactly 3 girls? A committee of 7 has to be formed from 9 boys and 4 girls. So which contains exactly 3 girls means out of the 4 you choose 3 into out of the 9 boys you choose 4. Is the point clear? So whenever they impose any condition, the condition needs to be satisfied first and then you will go for the other one. So second one is at least 3 girls. At least 3 girls means out of the 4 girls available, you will choose 3 into out of the 9 boys available, you will choose 4. or out of the 4 girls available, you choose all the 4, and out of the 9 boys available, you will choose
3.
5. Okay, that is the answer for second one. Okay,
Sir, is it not 3 boys? 9C3.
oh, it is 7, no, correct, yeah, you're right, it is 9C3. It is 9C3, correct. See, whenever you add the bottoms, no, that should come to the number they're asking. Clear?
Yes, sir.
Yeah. So at most 3 girls. At most 3 girls means
Maximum.
yes. So 4C0 into 9C7 or 4C1 into 9C6 or 4C2 into 9C5 or 4C3, 4C3 in, sorry, not 9C, yeah, correct. 4C3 into 9C4. Is that point clear? So this is the answer for at most 3 girls. Okay.
Yes, sir.
Yes. So let's see how many problems are there. 11, huh? If the different permutations of all the letters of the word examination are listed as in dictionary, how many words are there in this list before the first word starting with E? So it's simple, no? So first set will start with A. How many letters does this have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 blank spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So letter starts with A and we have 10 blank spaces. In those 10 blank spaces, you can do the permutations as 10 factorial divided by 10 factorial divided by which letter is repeating itself?
2 factorial.
That's it, no? So 10 factorial divided by 2 factorial. So what
Sir,
should the
N
next
also.
n is repeating how many times? 2 factorial, huh? Yeah. So after this, what should happen? The next set will start with E only. That's it. How many words are there in this list before the first word starting with E? These many are there. Am I right?
Yes, sir.
How many six-digit numbers can be formed from the digit 0, 1, 3, 5, 7, 9, which are divisible by 10 and no digit is repeated? So when you want the number to be divisible by 10, how many digits are there? 1, 0, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. The last digit will be 0 because the number is supposed to be divisible by 0 and no digit is repeated. So how many letters, how many numbers can you fill in the 5 blank spaces? Do it in 5 factorial ways. Am I right?
Yes.
6. The English alphabet has 5 vowels and 21 consonants. How many words with 2 different vowels and 2 different consonants can be formed from the alphabet? So from the 5 vowels available, choose 2. And from the 21 consonants available, choose 2. So what are the number of letters the word is supposed to contain? 4. So you can arrange those 4 letters in 4 factorial ways. 5C2 into 21C2 into 4 factorial. Okay. In an examination, a question paper consists of 12 questions divided into 2 parts, part 1 and part 2, containing 5 and 7 questions respectively. A student is required to attempt 8 questions in all, selecting at least 3 from each part. In how many ways can a student select the questions? So there are 12 questions, which is divided into part 1 and part 2. Part 1 consists of 5 questions and part 2 consists of 7 questions respectively. The student is required to attempt 8 questions in all. In the sense, a total of 8 questions are to be answered, but there is a condition. He needs to answer at least 3 from each part. In how many ways can the student select the questions? Can you tell me? So out of the 5 available questions from part 1,
5C3 plus
5C3 into
7C.
7C, 8 questions are to be attempted.
5.
3 are already chosen. 5C, 7C5 or 5C4 into 7C4 or 5C5 into 7C3. Make sense? So if you look at the bottom, right, everyone has minimum of 3 questions or more than 3 questions. Is the point clear?
Yes, sir.
In how many ways the student can select the questions is what they've asked. So selection means it is combination. What about the 8th one? Determine the number of 5 card combinations out of a deck of 52 cards if each selection of 5 cards has exactly 1 king. So how many kings are there?
4.
So out of the 4 kings, there should be 1 king into how many cards are remaining now?
48.
So out of the 48, the remaining 4 can be chosen. So 4C1 into 48C4 will be the answer. Is the point clear?
Yes, sir.
Yes. See, there are 3 more questions which I'm leaving it to you. You can solve it, right? So if you have any doubt, you can ask me in the next class, that is tomorrow. And see, tomorrow, please wait for the message. Today, actually, the rain stopped. If it is going to be severe tomorrow, wait for a message before you start to the class. Okay. So depending on the situation, we'll update you. If you don't get any message from us, it is going to be offline. Okay.
Yes, sir.
Yes.
Okay. So any questions?
No, sir.
Okay. Then we'll wind up.
Thank you, sir.
Thank you,
Thank
sir.
you, sir.